Welcome to CERAWeek 2015 online. My name is Sam Andrus. I'm a Senior Director with IHS Energy, focusing on North American natural gas. With me today is Matthew Scullin, founder and CEO of Alphabet Energy. Alphabet Energy was selected as a 2015 Energy Innovation Pioneer, featuring those companies that are on the leading edge of new technology in the energy space. Welcome, Matthew.
Thank you.
So, Matt, tell us a little bit about Alphabet Energy. What is Alphabet Energy?
Sure. So Alphabet Energy makes waste heat recovery systems that employ a new thermoelectric technology, which is a solid state material that turns heat into electricity. So we package this new material into turnkey systems for the oil and gas industry that can take exhaust and turn it into power.
So what was the impetus for developing this technology? How did it come into being?
So
what was the spark?
Sure. So waste heat is a huge untapped resource.
Yeah.
So we have waste heat in many different locations, oil and gas being just one of them. And in particular, these sort of remote locations that use 1 megawatt engines to generate power have a lot of waste heat. But beyond that, there's a ton of waste heat from other sorts of power plants, industrial furnaces, vehicles. We waste, over 60% of all the energy that we produce. So I was really interested in looking for technologies and products that could begin to make a dent in this problem that is waste heat, that could have good return on investment for customers and fit the other criteria that customers such as those in oil and gas need in order to deploy a power generation product. So the existing technologies out there, like the organic Rankine cycle, are very cumbersome. They have a lot of moving parts, rotating machinery, high pressure, working fluids, and really don't fit a lot of the standards that oil and gas, for one, has around simplicity, reliability. And so thermoelectrics are a technology that are solid state because they're just a semiconductor material. So you can almost think of them as a solar panel for heat. And I had been doing my graduate school work at Berkeley, where some new thermoelectrics had just been invented that were very efficient and very cheap, and thought that they could have good product market fit in industries that needed high reliability, high simplicity, and good ROI. And so we licensed this technology out of Berkeley, and then subsequently licensed the technology out of Michigan State, developed a lot of additional intellectual property around these systems to turn waste heat into power.
So is this still a laboratory product? Is it out in the field? What stage are you at with this product at this time?
Yeah, so Alphabet has successfully spun these technologies out of labs. We've scaled the process to produce them at large scale. And then we've also, as a result, developed full turnkey generators. We've gone from the very start of the process all the way to finished products, and we've deployed them to several oil and gas customers. So our first deployment was with the Canadian natural gas company Encana, who also led our Series B investment a couple years ago. We've also deployed a unit into drilling in Asia, and in addition into another compression application in the United States.
So is it remote location? I mean, on the well side, on the drill side, what's kind of the primary target market that you're looking at right now?
Yeah, so within oil and gas, we're really focused on two areas. One is midstream compression, so gathering line type infrastructure, where you typically have 1 megawatt or roughly 1 megawatt recip engines that are remote, so off the grid. And you typically have power loads that might be anywhere from a few kilowatts to a few dozen kilowatts for things like SCADA systems, other telemetry, other loads. And I think what I'm hearing here at CERAWeek is that the digitization of oil fields and gas fields is a growing trend. And so there are more and more electrical requirements even at these remote sites. And so we can help to power those and eliminate the need for small diesel gensets, not only eliminating the fuel that's required, but also actually their operation entirely.
The emissions and everything that comes.
Right, so the noise, the emissions, it's something that can help these operators to be green, but it also pays itself back pretty quickly. So in these applications, we can give payback times that are measured in months to a few years. We're not talking about really long payback times here. So they're good return on investment first, but they can also help a company become more green, reduce hassles around permitting with noise and traffic to their sites and things like that. And so similarly in upstream, putting the unit on an engine that's used for drilling can offset some diesel fuel that's being used to generate power in gensets and drilling operations.
Yeah, megawatt's probably not the main system, or driving the main system on a drilling rig, but it probably would help with some of the auxiliary services or ancillary services on a rig.
Right. So you've got typically a few hundred kilowatts of electrical load on the rigs that we have experience with, and this can help to offset some of the fuel used to power those.
How about in water? I remember seeing some of these real small downhole pumps for water. It would seem like this might be a fit for pumping water, or pumping any fluid up out of a well.
Sure. I mean, in general, if you have electrical loads, this unit can help you to offset those electrical loads with what you're already powering them with. And if that's an off-grid application where you're using a genset to power those loads, that genset can be expensive and it can have high O&M costs. And so the beauty of a thermoelectric is that because they're solid state, they're very reliable. So our units, we package them into a 20-foot shipping container, even though the technology itself is a small fraction of that container inside. But it's a turnkey system, it installs very quickly, and then there's virtually no maintenance, and there's no operator required because it's a solid state system.
So it'd be all skid mounted, you can just bring it in and drop it in.
Yeah, that's right.
So what do you use as the heat? Are you taking a stream of the gas off of the system, or
right?
How do you get the initial flame?
We're taking the exhaust directly from the engine and flanging it right onto our unit, and the exhaust flows through our unit, heats up the thermoelectric materials, and generates power. So it's very simple to install and super simple to operate.
So Matt, another concern out in the oil patch these days is the issue of flaring. Is there an application of this technology that might help be a solution or a potential solution to this issue of flaring?
Sure. So it's a good question, because actually the technology inside of our turnkey generator, which is called the E1, is actually very widely applicable. So we do have a lot of interest in using our technology for flare gas applications, but I think more broadly speaking, and to dive into how the E1 works a bit, inside the E1 we have 32 what we call our power modules. Okay. The power modules are about 2 feet square, a few inches thick, and each one of them is sized for about the exhaust of a car or truck. So we can use the power module in a wide range of applications, whether or not it's waste heat or sort of primary power. If you're actually burning a fuel to generate thermal energy, we can convert that into electricity. So we really see the power module becoming a platform technology over time. And since we released the E1 last year, we've actually already seen very concrete steps towards the power module becoming a platform for power generation. For instance, we're working with automakers to have the power module installed onto cars and trucks, to take the load off the alternator, improve fuel efficiency. We've done a deal with a major furnace maker who will use the power modules for industrial waste heat. And there are many other applications that we're working with partners on to get the power module into power generation.
So these containers, these 20-foot long heat exchanger in a box, are they thermally insulated then, and you're running heat? Yeah, you said you have 32 of these things. You just run heat through this box on the inside then?
Yeah, exactly. So basically the E1 is a really simple turnkey system. Drops down next to a 1 megawatt engine or close to 1 megawatt, and the exhaust flanges right onto our system. We send the exhaust from the engine right through the 32 modules that are inside the box, and it basically runs in the solid state, no moving parts, no operations or maintenance for a long time. And these modules can kind of slide in and out like blade servers, so they can be upgraded over time. And we can also, build systems that have fewer or more modules in them.
Yeah, so they may not be a long-term solution to flaring, but at least they're a potential path to not waste all that heat until we can get to the point where we don't flare anymore.
Yeah, potentially. I mean, I think in some cases in many cases, our power modules can be a long-term solution for power generation. I think flaring is to be determined right now.
Great. Well, Matt, thank you for introducing us to Alphabet Energy, and thank you for joining us with CERAWeek 2015 online.
Thank you.